So now we'll get into the technical presentations. First up is Becky Nix.
But I wanted to present a domestic scan tour that we completed last year. Just real quick, I'll give an overview of what the domestic scan tours are. This is a chance to either go out to multiple sites and see different technologies, different items of interest, or to pull a whole group of different states together and try and have those discussions and look at items that are particularly a global issue for multiple states, multiple agencies. And it gives everybody kind of a chance to bring up what their issues are, kind of like this group does, what the issues are, what different details are being used, what new technologies are being used, lessons learned, and just kind of bring a whole group together and look at what those common interests are. Typically, these statements are submitted by different states or different agencies, so they are definitely ones of interest to a bunch of different groups. One of them that we really felt was a big overarching issue is bearings and joints. They're a really minor component of the bridges, but they can have such major overarching effects for the entire bridge as a whole. If a joint fails, you're suddenly getting leakage that's getting onto your abutments, your beam ends, your bent caps, and you have a lot more accelerated deterioration that you're seeing if those joints fail, as well as bearings. If you have failures of your joints, you're now failing on your bearings as well. You're getting accelerated deterioration of your bearings as well. So we wanted to take a look at a bunch of different bearings, what different details are being used in different states, if there are best practices, if there are certain systems that are working better than others, how they're being maintained. So what we tried to do was take a look at a bunch of different states. We wanted to look at severe climates. We wanted to look at high precipitation. Are there areas that there's a lot of snow and freeze-thaw? Are there areas where they're applying a lot of salt? Highly traveled routes, and some of the larger bridges, and also different states that have had successful details. So when we first set up this scan tour, we kind of looked at, does it make sense to go out to a bunch of different states and look at the actual bearings and joints in the field, or does it make sense to bring everybody together in one room and have them provide details, provide pictures, and provide information back? And that's what we ended up doing, because there's so many different types of bearings and so many different types of joints that to try and find areas that you could get a large sample, it didn't really make sense. So we assembled a team where we had several different DOTs represented, 2 universities as well as FHWA. And then from there, we also had several other states that were not part of the SCAN team, but they came and provided presentations to us. So we were trying to get extremes throughout the country. We wanted to get both coasts represented, get north and south, and try and get a bunch of different climates, as well as different details that different states were using. And so we wanted to get a large variety of different states to come out and present what they're doing for their bearings and joints. What we wanted to do is look at kind of what best practices were and be able to provide some recommendations back to the T2 committee as far as where we wanted to go for research, and put some of those best practices out there so that we were learning from each other as opposed to trying to recreate the wheel. We wanted to look at what was working, what wasn't working, were there particular details that we could be sharing, and get this published all in one location in one document that could be a resource to all states as well as local agencies, and also potentially lead some additional research for the T2 committee. First activity that we did was send out a full survey of amplifying questions. It was a really detailed document. I think it was about 10 or 12 pages of questions going into what successful strategies had been used, what was unsuccessful, what was working well, but also looking at what was not working well. We wanted to look at what new technologies were out there. Maybe there were things that were being used on the East Coast that hadn't made its way out to the West Coast. Looking at what training was taking place for installations, what the requirements were for that training and that installation, what maintenance was being done in-house as well as through contractors, how different states were handling cleaning joints, and whether that was being done systematically or not. We wanted to look at how conditions were being documented, as well as what performance measures were being set by these different states, how rehabilitations were happening, what corrective actions were being taken as the bearings and joints reached the end of their service life. And then another aspect that we looked at that is overarching beyond just bearings and joints, but was looking at our succession planning. As we have turnover at the DOTs and we have people moving around to different jobs and different positions at the DOTs, sometimes we're not transferring that knowledge as far as what training has been done, what people know as far as how to detail them, what's working, what isn't. If we don't pass that information on, then not only are we recreating that at each individual state, we're now recreating any of that information within the state itself. And so we wanted to kind of look at ways we could document and pass that information on and make sure that we weren't recreating the wheel every time somebody changed a position. We looked at design, construction, inspection, and maintenance for bearings as well as expansion joints individually, and then we looked at some overall conclusions. So each state brought kind of some examples of what were different bearings that they were using in their state, what they had used in the past, what they were no longer using, or what they were moving towards. And there was a lot of discussion around why they were using certain details and why they were not. I think a big part was trying to simplify designs. There was a lot of discussion around how different states were handling uplift and whether or not the bearings were being designed to resist uplift. Another thing that we looked at is once those bearings reach the end of their service life, during initial design, did we take into account ways to replace those bearings? A lot of times, if it wasn't considered up front, now you're doing additional work to find ways to jack the bridge to replace the bearings. And so if we can take care of that up front and have jacking locations during initial construction, we're not having to modify the structure when those preservation and rehabilitation activities need to take place. We looked at why different states are selecting different types of bearings, what's the most common bearing types, and it seems like most states now are going to the steel reinforced elastomeric pads whenever possible because they're low maintenance and low cost. Pretty much every state has gone away from both rocker bearings and roller bearings, moved towards the pot, disc, and spherical bearings for those high rotation, high movement bearings. Some states have strict bans on pot bearings, while others prefer them. California is almost exclusively spherical bearings for the high movement joints. And then it's kind of a split between all the states on whether they prefer pot bearings to disc bearings. We also had discussions as far as what different design methods were being used for the elastomeric bearing pads. We looked a lot at what maintenance issues were coming up with elastomeric pads walking out from underneath the girder ends and what differential on the beam could be accommodated without flattening the end of the beam to sit on the elastomeric pad, whether or not it was bonded to the abutments in the different states. As of right now, for the sliding surfaces for sliding type bearings, AASHTO is only specifying PTFE, but we need to start looking at other materials as industry changes and industry adapts. What other materials are out there, and do we need to be updating our specifications? Does AASHTO need to be looking at different sliding surfaces as well so that we can start taking what industry is doing and putting those into practice and staying up with technology? Right now, the disc bearing design specifications, it was kind of a general consensus that it's lacking detail, and there needs to be a more complete provision to kind of give additional guidance. We also had a lot of discussion that in the European market, their bearing design is a lot more performance-based, and their specifications are performance-based, so it's not necessarily specifying one type of bearing, it's this is the amount of movement we need to accommodate for. And so we've started looking at, is that something we want to be developing in the U.S. in order to kind of push that innovation and make sure that we are moving forward as an industry and we're encouraging innovation. So then we were also looking at some states want the bearings to be able to accommodate all of the initial creep and shrinkage, where other states, after those initial things take place, they reset the bearings back to zero, and so that doesn't need to be accommodated for in the long-term design. We looked at during construction, a lot of the larger scale bearings are not necessarily being handled appropriately. Sometimes they're getting opened up in the field, or it's not understood what the complexities are. And so they're not being handled properly, and you have a failed bearing from day one because it hasn't been handled in the field appropriately. Another thing that we've really seen is as steel prices fluctuate, it's changing the cost of the bearings, and so we need to be accounting for that in our design and our construction costs. So during inspections, we need to be looking, because we are going to so many of the elastomeric pads, are we checking to make sure they haven't walked out? Are they bulging? Are we starting to see deformations beyond what we're anticipating in the elastomeric pads? And getting training of the inspection staff to make sure they know what they're looking for and they know when it's a critical failure that needs to be addressed. We've kind of gone away from the rocker and roller bearings as a nation because they are high maintenance. If you do get water on them, they have a tendency to rust and seize up, and now you're not getting the movement that you're anticipating. Looking at going from the rocker bearings and the roller bearings, if you're rehabilitating a structure, we had to look at how different states are handling differences in elevations. Now you've gone from a tall rocker bearing to a significantly smaller profile elastomeric bearing, and so how are you building up the abutments? How are you building up the bearing seat? We really broke the group up into, we looked at bearings independently, and then we looked at joints. We did have several manufacturers come out as well, and they presented on their different systems, and so that really gave our team a lot better idea of what systems were out there, gave us a better understanding of what was available now. As far as the expansion joints, there seem to be a lot of different systems out there now, and this seems to be one of the biggest maintenance headaches that every state is having to deal with. Short durability, glands that are getting punctured, installation that isn't happening necessarily correctly. We tried to look at some of the major problems that we were seeing. A lot of times if a joint isn't installed correctly, if it's installed too high, then right away from day one you've got snowplows coming through and tearing them up. And a joint that's supposed to last 10 or 15 years, now you've got one cycle out of it and you've started leaking onto your substructures. We wanted to try to document what different states were looking at as far as their small, medium, and large movement definitions. And seemed like almost every state was looking at your small movement joints were 0 to 2 inches. Medium was 2 to 4, with the exception of Washington that was looking at up to 5 inches for your mid-range joints, and then greater than 4 inches for your larger modular style joints. We also wanted to take a look at what kind of SKUs were being allowed for the different joint types. And then the biggest thing that we kind of looked at was going away from joints completely and trying to remove as many joints as you could on a bridge. This seemed to be one of the biggest overarching discussions on our bridge joints is anytime you can remove them, try to remove them, because then you don't have that option for leaking and degradation over time. We looked at different materials to do link slabs. Some states are doing strictly standard structural concrete, while other states are looking at ultra high performance or other polymer style concretes in order to create those link slabs and close up those expansion joints over time. We also looked at different terminologies and what different states were using for their terminology and try and get a consistent nomenclature for the different joints. It seems like a lot of times now we're going away from compression seals a little bit and gone quite a bit more to our strip seals for the mid-sized joints. It seems like most states have gone away from the finger joints as well and gone to modular joints for the large style. For construction, we think it's best practices that installation procedures are submitted up front so that staff can be trained. The inspection staff knows what they're looking for, what needs to happen, and what those critical items are during construction. Having a pre-construction meeting and discussing up front how the installation needs to take place and what those critical items are. We recommend having manufacturers' representatives on site so that they're able to look at the prep work that's taken place and give recommendations. A big thing is looking at your installation temperatures. Are you giving the appropriate opening for what the current temperatures are? You don't want to be placing a bearing or a joint width at 70 degrees that you anticipated to be setting at 20 degrees, or you're not going to have the movement available that you need. As more and more concern gets put on traffic delays and on reducing construction impacts to the traveling public, a lot of times it's hard to get a full bridge closure in order to be able to replace an entire joint, especially on the larger joints where you're replacing the headers and you've got cure time and everything else. So we looked at, are there ways that we can reduce construction time and reduce those closures? How do you connect the different sections if you have to phase it? Can you run a discontinuous gland and still be able to fuse it and get a watertight joint? especially with some of the modular joints and having to do field welding in order to get those installed. We also looked at that concrete pourback. What type of concrete is being used? Is it a self-consolidating? Because a lot of times there is a lot of anchorages from those joints that have to be consolidated around. And so how is that consolidation taking place? How are you ensuring that you're getting proper consolidation so you get the life you need out of the joint? Something else we looked at was using ultra-high performance concrete for the headers, but then the question came up of how do you remove that when it comes time to replace the joint? Because that joint most likely is not going to last as long as a bridge is. So how do you get that material out? We looked at the plug type joints and how you get that proper bond and how important it is to have the proper prep work take place prior to placing the joint. Also tying the joints into your barrier, making sure that it's turning up at the joint so you don't have water leaking out right at the barriers and dumping down onto your substructure. Sometimes with the wider joints, you need to also make sure that you're not creating a snag point, you're not catching it with snow plows, you're not creating something that cars could snag on. So we looked at additional details for that as well. One of the biggest things is getting an active maintenance program in place, making sure that the joints are being cleaned, making sure that there's not debris accumulating that's puncturing the joints, and then also making sure that we're documenting what types of joints are going into place. With as many manufacturers as we have out there, if you need to go out and replace a strip seal, it's going to be different based on the manufacturer, and so you need to have that documentation up front of what joint type you have, and so you know what replacement pieces you need in order to be able to rehabilitate it rather than fully replace the joint. Some states like Utah, we do very little joint maintenance in-house. We'll clean the joints and that's about the extent of it, where other states like Minnesota have full bridge maintenance crews where they're going out and doing full replacements of the joints. So some of the bigger overarching is obviously funding. Funding is a problem for every type of bridge work, for every DOT, I'm sure. I don't think there's anybody out there that'll say, hey, we've got too much money, you can take some of that back. So trying to make sure that we're being efficient and effective in how we're maintaining our bridges and maintaining the joints and maintaining the bearings is one of those ways that we can make sure that we're putting a small amount of money in that's going to have a large return moving forward. Attraction and retention of staff has been huge. How are you passing on that information? If you can't retain staff for extended amounts of time, it used to be that somebody would get into a job and they're there for 20, 30 years. They're there for their entire career. And now people are moving around every 2 or 3 years and you're changing and you're losing that institutional knowledge. And so trying to find a way that we can kind of carry that forward. And then also looking at how can we encourage innovation? How can we encourage moving the market forward, finding something better, finding something that's more effective, something that's more durable and will last longer. We did try to document what the different practices were throughout the states and what the reasoning was between the different practices that they were using. Looking at overall life cycle costs and how you can reduce those and what kind of the best options were to decrease the life cycle costs. So maybe your upfront cost is higher, but over the life of the joint and the life of the bridge, you've reduced your overall cost. We tried to document the different common types of bearings and look at what was no longer being used. And then also going to that jointless bridge, like I mentioned, kind of the motto of our week out there was the best joint is no joint, which I know some of you don't want to hear, but anytime we can eliminate them to try and do that. We recommend trying to develop some training tools, trying to have some sort of documentation that can be passed on as people change jobs so we can kind of retain that knowledge and retain that institutional knowledge. And so this is part of what we're putting together for documentation for our scan, is to have some of that information that can then be developed into some training tools that can be passed on. Also providing some selection guides. When is it appropriate to use different bearing types? When is it appropriate to use different joint types? And then also looking at what's an effective way for us to start gathering field information, the information on what actually happened during construction. Is that something we want to be documenting in our bridge management system? Do we actually want to be calling out somewhere that specifically what type of joint we used, what type of bearing we used, who the manufacturer was, and how do you keep that information of what the recommended maintenance is? And so trying to find good ways that we can develop that and also maybe get a national database, kind of like we've done with some of our patching materials and some of that, so that all of the different DOTs can see that and see what's being used in different states and what's working and what isn't. There were some inconsistencies between the LRFD design spec and the material specification that we're going to be working with the committees in order to try and resolve those. And then also looking at writing a design specification for disc bearings. So we've got a lot of action items coming out of this to move forward, but we gathered a lot of great information and we should be publishing that final report soon. That'll be available to everyone and that should be out in the next couple months. Thank you, and does anybody have any quick questions on that?
Not a question, just a comment. I just want to compliment you on getting everybody's perspective as well as thinking about maintenance, because maintenance is the place that often gets left out when optimizing design. And so your whole commentary about thinking about what happens after you put something in and is it maintainable, I think that was spot on. So I just wanted to say that was nice.
I think that's it.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.